So shall we start the session, sir? Balram, sir. Hello.
Yeah, no problems.
Okay, sir. Okay, sir. Okay. Good afternoon to one and all. So if you are not stubborn, you will give up on experiment too soon. And if you are not flexible, you will round your head against the wall and you won't be a different solution to a problem you are trying to solve. With this note, I would like to welcome Balarama Murthy, data scientist, George Institute of Technology, Hyderabad. Welcome you, sir. Sir is an art and works artificial professional with a 17 years experience in development, training, administration of various emerging technology. Sir is currently working as a data scientist in George Institute of Technology, Hyderabad, Telangana, India. Sir has appointment as Hadoop trainer and placement from KMIT and shifted to Delhi Paradigm for developing Hadoop and integrating Hadoop with Tesol. After that successful completion of this task, Sir appointment as being a data science trainer for Virtuosa Center of Excellence in KMIT. Sir has honored as best faculty and the best social media utilizer. With the short introduction of the today's resource person, I welcome Sir for his presentation. Welcome you, sir. The session is hand over to you. Thank you, sir.
Thank you. Thank you very much. Yeah. Hi, everyone.
Oh, yes, sir. It's audible, sir. Sir, it's audible, sir. Hello, sir. It's audible, sir.
Yeah.
Okay.
Yeah. Okay. Fine. Yeah. For a moment, I will stop the video for better quality of the network. So,
Yes, sir. Yes, sir. Sure, sir.
Yeah. So afterwards, again, I will start the video, right?
Hello, sir. Hello, sir. I think you have muted the voice, sir.
Hello. Are you getting my voice now?
Yes, sir. Now it's audible, sir.
Yeah. Okay. Yeah. So I think it is muted. Yeah. So in today's session, I want to introduce the big data requirement of the big data in healthcare, why we should use the big data concepts, how it is different from some other concepts. Already we are using so many technologies and so many tools in our computer world. So what is the speciality of this big data? And also how it is related to other fields, other technologies. And also what is the relation between this big data and data science, and also artificial intelligence, machine learning and deep learning. What is the interrelationship between these concepts? And we will start with the Hadoop concepts and where the big data concepts are required in healthcare. And also I will list out the healthcare applications in the big data concepts on the big data concept, right? So and then I just want to introduce the concepts of the HDFS and MapReduce and also all the ecosystems and brief description about the architectures of various Hadoop ecosystems, and also I will try to cover the Spark concepts in this session, right? So if time permits, again I will show you the cluster, I will show you the basic execution of some programs also. So this is the agenda for today. So I'm from KMIT and NGIT. So I'm working as the data scientist in the NGIT and KMIT. These two are under the same organization, and we are working on the drone technology, missile guidance, and also the medical imaging and digital pathology. All these researches are going on in our organization. So this is brief about myself. This is Balram Murthy. I'm the Hadoop certified professional and I have 20 years of experience. Already sir has introduced. So let us start with the concepts. Now in this data, we will start with the data sources, analysis of the size of the data. What are the sizes of the data? What are the measures that we will discuss? And then data from the healthcare. What is the data from healthcare environment? I think I need not explain much about the healthcare in this session. I'm not touching much in the about the healthcare concepts, core. And of course, healthcare is also one of the domain. And then data science. And then we will discuss about the Hadoop and ecosystems, Spark, and then applications of healthcare on big data environment. So that we are going to discuss. Of course, the order may be a little different. Now let us start with this now. So I'm just confirming my voice is clear and the screen is also synchronizing with my voice. Is it clear?
Yes, sir. Sir, it is clear. Go ahead, sir. Sir, it is clear. Everything is perfect. Thank you.
Fine. Yeah, I'm going to that. So first of all, we have to think about the data. Lots of data is generated from last number of decades. It may be from 3 or 4 decades. Lot of data is getting generated. So what is that lot of data is generating? What the data and what is the sizes of the data? We know that it has crossed GBs. Actually, in my first mission, when I started my career, where at that time my hard disk was my system hard disk was 20 GB. I started my work on 20 GB. Of course, I worked on 4 GB hard disks also, right? And I started with the 20 GB hard disk and Windows 98 version, 95 and 98 versions. So at that time, the 20 GB is also very high. And 40 GB later, I started using the 40 GB. The 40 GB was also very less now. And after that, 100 GB was there, and so many things are there. 500 GB, 250 GB, 500 GB, and then 1 terabyte. Now we are using. Most of us are using the laptops with 1 terabyte hard disk, right? Now, what we are storing actually the data. Here, the data means 1 terabyte hard disk is also not sufficient nowadays. That is very surprising thing. How many of you agree with me? How many of you are agree with me? You can respond in the chat. Yes, 1 terabyte is also, yes, 1 terabyte is also very less. We are feeling that. But why we are feeling that? 1 terabyte is very huge amount of data. It is very less. It is very, we will feel that it is very less if we are storing the movies, if we are storing the songs and very high resolution pictures and all, then you will feel that it is very less. And if you are working on the research and if you are working on the very large set of data, then also you may feel like that. But most of the systems are filled with the movies and others only. So let us see here. What are the data generators, first of all? And what is the data sizes going beyond that? Now, GBs, all of us knows GB, gigabyte, and terabyte. Terabyte is also there. And the next level is, what is the next level? It is the petabyte. Most of you know petabyte also. What is the next level of the petabyte? What is the next level of petabyte? Can you please answer this? Next level of petabyte. If anybody knows, please let me know. Because the entire topic is depending upon this one. Next terabyte to next level is petabyte. Next step is exabyte, and the next step is the zettabyte. And the next step, what is the next step of zettabyte? Anybody knows? After zettabyte, next step. Next step is yottabyte. Yes, yottabyte. And then next step, what is the next step of yottabyte? Next step is brontobyte. Brontobyte. It is the next step. Okay. So now we are going the levels, next steps, meaning that it is going to increase more petabytes, exabytes, zettabytes, like that. Now, where can we store this much of huge data? Can you store in a single machine? It is not possible. Terabyte, even if you have 1 terabyte of data, if you want to take the backup of 1 terabyte data, it is very difficult. It is not an easy task. And okay, you can store that. Then how can we process this much of data? If you have large amount of data, then how can we process it? A small dictionary, the dictionary, actually not small, very large dictionary. Oxford dictionary can be stored in less than 1 MB. Oxford dictionary can be stored in less than 1 MB. You just imagine that if you are using the system and if you are using the storage device only for the valuable data, then how big it is. You can imagine how big the 1 GB it is. You can imagine. Okay, log files are in the GBs and terabytes. You know, log files are very large. So how to handle that much of log file? How can we analyze that log file? It is very difficult. That is the how to process it. And can the centralized servers handle the situation? No. And how to recover the missing data once the server is down, once the machine is crashed? Can we recover the data? No, there is no answer for that, for this much of data. And Hadoop is the solution for all these questions. And we are going with the sources of data. You can imagine every 1 minute, for every 1 minute, this much of data is generating. In every 1 minute, 72 hours of videos are getting uploaded in YouTube. In 1 minute of time, 72 hours of videos are getting uploaded. And how many emails are generating? You can see that. And how many Google searches are happening? And how many Facebook updates are there? And how many tweets are there? How many WhatsApp messages are there? How many, all these are the various analysis and various survey was conducted. It was the survey which was conducted in 2016 or 17. It is not the latest one. In 2016 or 17, it is the survey which was conducted. Please imagine what is the next step. What is the today's situation? You can imagine that, right? So lot of data is generated. And now data generation analysis by IDC. IDC means International Data Corporation. They have conducted some analysis, and what they have estimated is they have estimated the approximate size of the digital universe. In 2005, it is 130 exabytes of data was generated in the network. 130 exabytes all over the world in all the fields. And in 2017, which was expanded to 16 zettabytes. 16 zettabytes. See, 130 exabytes and 16 zettabytes. 16 zettabytes means 1 zettabyte equal to 1024 exabytes. So that you can imagine 16 zettabytes of data was generated. And 2020, the estimation was like that, 40,000 exabytes by the year 2020. But it was more because of the COVID situations. The digital usage is increased a lot. Even our session is also conducting online. This is also going to record in the cloud. It is also going to record. So how much data is generating? You just imagine if it is conducted offline, this much of data is not generated. it might not generate this much of data. But now we are generating a lot of data. And these observations and all these observations have become the challenging that has eventually led to birth of the new field that is called the data science. We have the data, large amount of data to handle that, to analyze that. We have to use a different field that is called the data science. And data repository for healthcare. I'm not very keen about the healthcare things, but I'm trying to cover this because the healthcare is the main domain at this moment. So see here, the healthcare, it is the multidimensional system for the prevention, diagnosis, treatment of health-related issues. Prevention, diagnosis, and treatment. For all these things, we should have so much of devices, so much of data is generated, so much of reports are generating. And it may be the text data, it may be the image data, it may be the signal data, it may be the sensors data, it may be the different kinds of data, financial data, it may be the financial data. So much of data is generated. So what are the types of data generated that may be covered in our other sessions? But here the point is, lot of data is generated. That is our point. So how to handle this much of data? The major components of the healthcare system are the health professionals like physicians, nurses and all, and supporting staff, and also health facilities like clinics, hospitals, delivering medicines and other diagnosis treatment technologies. So all these are the various things. MRI scan, it is generating a lot of data, and CT scan, it is generating some data. Based on that, we are generating the reports. The data is different, and report generation of the reports. After taking the MRI scan, that MRI films, that they cannot be understandable by the normal person. So they have to generate the report. Again, that report. How to analyze that picture and how to analyze that MRI data and CT scan data and X-ray data, and also the prescriptions and various medicines, various treatments, all these are lots of data is there that has to be verified and that has to be stored. Of course, financing. Whenever we talk about the healthcare, immediately we will come to one concept that is called the insurance predictions. Most of the insurance companies are using the data analysis. They need it because of the treatment and everything. They have to predict how much insurance is required. that is their main job. It is useful, very much useful for the financial teams like insurance companies. And of course, it is very helpful for the doctors and all the physicians and all, right? And then now, the health professionals are responsible for different kinds of information. That is a patient's medical history and medical and clinical data, and also other private and personal medical data also should be maintained. And another thing is electronic medical record. It is also generated very nicely, and our global data will be maintained. In the global environment, our data will be maintained. Whenever we give our identity, immediately you will get the information. Medical record, personal medical records are generated. We are using that. And personal health record is also there. And electronic medical record, it is from the so many diagnostic centers. You can easily find that in the so many diagnostic centers, electronic medical record, and as hospitals also you can find them. And if you give your patient ID, you will get the entire medical records, right? And the personal health record. Everyone can have the personal health record. You may go to one hospital or different hospitals or different environment, different places. Even though the personal health record will be also maintained, that can be also maintained digitally. And medical practice management, which treatment was done in the particular hospital or particular patient, for the particular patient, which treatment was done, what are the bills generated, what are the reports generated, what is the health condition of the patient. All these things have to be maintained. All this is comes under this medical practice management software, comes under this. So many softwares are also generating, and it is developing a lot. And electronic healthcare records, and they are maintaining, actually National Institute of Health, they are maintaining all of us portal, and in that everything, every medical record will be stored, and it is providing the security also for the patient's data and over the number of years. And so a lot of data is generated. Why we should maintain this? Because to analyze the health for the current for a patient, for example, right now I am having these symptoms, I have these habits, I have these symptoms. So what are the medical problems I may face that I have to predict? If I am able to predict all those things, then I can take the proper treatment. We can prevent the diseases. So all these are required. So because of that reason, old records, if you are able to analyze the old records and existing patients information, then it will be very beneficial. And it includes the medical imaging, socio-behavior, and environmental data. Environmental data is also very important. All these are affecting a lot, right? And the current situation, COVID situation, is also affecting our health because of it. Even we are not affecting with the COVID, we are facing so many problems because of the work from home. We are getting the obesity, we are getting the fat. Am I correct or not? Are you agree? Are you agree with me? Because of the COVID, so many diseases are generating, and stress, so much of stress is also generating. How many of you agree with me? Please respond. I'm waiting for your answers. So all these are affecting, all these factors are affecting our health. So all these are comes under the points to be considered for analysis of the patient's analysis of the patient's history and patient's analysis. So this is the main concept actually. And then now biodata, a big data in the biomedical research, and it is very vast subject and very tough subject to understand and to maintain. Also lot of data is generated in this actually biomedical systems such as human cells, and all these are having so many things. Next generation sequencing, NGS, and the genome analysis, studies on the genomes, and whatever is there in the medical terms, there is the omics. Omics means whatever the term is there, genome, for the genome, genomics, like that. There are so many concepts are there, and transcriptomics. So like this, so many studies are going on which are generating a lot of data, which are required to analyze so much of data. And the big data in that, NGS has greatly simplified. It was able to simplify the sequencing and decrease the cost of the generating whole genome sequence data. Actually, it is very huge amount of data, but they have found some solution to reduce the cost of that analysis of that data. Very huge amount of data is there. How can we handle that much of data? It is not possible economically. It is not possible to hold that much of data, right? So we have to find some solution. Of course, the solution is there in our hand, in the technology. The solution is there in the technology, and NGS technology has resulted in increasing volume of biomedical data that comes from the genomics and transcriptomic studies. And combining of these two, genomic and transcriptomic studies, we are getting, the professionals are saying that we can achieve more, we can analyze more about the patients. Anyone is from the biomedical concepts and in that field, in this seminar? Can you please Anyone is there who are working under the biomedical and healthcare units? Anyone is there? If everyone is from the technical side, okay, then okay, fine. Let us continue. Yeah. So this much of data, so much of data is generated here, and we have to analyze this in this house. And IoT, this we know, all of us know about this IoT. The objects, all the objects are having some sensors. They may have some sensors, and they may have the watches also may be there, refrigerators and health monitoring devices like bands. Bands are there, health bands. We are using health bands. The health band is generating the sequence. It is taking the sensors, and it is based on the sensors. It is analyzing so many things, and of course the IoT devices. All these are whatever you are seeing the IoT devices. They are considering that into this, meaning that see automatic tagging, meaning that automatic what is the toll gates in system and signaling system, and we are paying the digital payments. All these are comes under this only. So we are doing that IoT and radio care also. And I will give you a small example regarding this. See, if we fix some sensors, yeah, if we fix some sensors and the cams, CCTV cameras and all in our home, at our home, I'm having my hand wristband. I'm having my health band. Based on that can be connected to cloud. The cloud is connected to entire world. So whenever there is some problem in the heartbeat, it may be identified. It may alert the nearby healthcare units, and it may alert someone. So something is happening. Some robbery is going on. Immediately, it may be identified. It may be given to the sensors will be identified, and it may be given to the particular authorities so that they can take the actions. All these are the examples for the analysis of the data. So, and then big data from omics. They see here Spark SEQ and SAMQA, ART, and this map, SUQ bear, and all these are the various terms, various apps and applications, and all these are designed for the all the omics. Omics means the preceding may be something else, genomics, and already I have given some examples like that. So all these are designed. And how it is possible to design? Because it is having huge amount of data. So how can we handle this? That is because of on top of Hadoop only, all of them have designed. Most of these applications are designed on top of Hadoop. So if you are able to understand what is the Hadoop concept, Hadoop technology, then you can handle all these concepts, and you can easily understand how to handle the data with these applications. I hope you are, I'm with you. Please respond. Am I with you? Am I with you? Or I'm going to somewhere else? Yeah. So now I'm taking you into the big data concepts now. Big data and data science concepts. Let us go one by one. Now, see here, we have a very large field. It is called the big data, and it is having the various properties like volume, velocity, variety, value, and veracity. These are the various properties of the big data. Volume means very large amount of data, huge amount of data. That is the volume. Velocity, it should be accessed very fast. If you give one query, that should be retrieved immediately. That is the velocity. And variety, different varieties of data, different formats of data may be available. It should be handled different varieties of data, and it should have some analysis also. There is a value, statistical values. If the data is able, if you are able to express the data in the mathematical or statistical form, that can be easily handled and it can be used for it is the valid thing. So the value is there. The value can be considered again in the different ways. The value can be considered from the mathematical point of view. Anything is expressed in the form of the mathematics, you can analyze that very easily. You can write the program. That is the mathematical point of view. But from the other point of view, the relevance of the data, if you are working on the healthcare unit, if you are getting the, of course, healthcare unit is connected to all other units, so it may be relevant data. But if you are working on the sports data, if you get the stock market data, then what is the use of the stock market data for the sports analysis data? It is not. Of course, it may be another point of view, it may be useful, but at the current situation, it may not be useful. Value comes from there also, from the perspective also. And variety of data, different veracity. Veracity means if you collect some data, the data may be having some problems and it may have some noise, some extra data, unnecessary data. So we have to handle that. The big data has to handle that also. All these are the properties of the big data. There may be something. Some tools are available for that. And in this, Hadoop is the very important and a very effective tool. We cannot say that it is the tool, it is the framework. It is an effective framework for handling the big data. And what is the data then? Of course, Google is also there, but it is designed for only Google products. And big data, it is not only about the size of the data, it is about the value within the data and the data which cannot be processed on a single machine or single server, that can be considered as the big data. These are the two simple definitions for the big data. So many definitions are there. I'm taking these two definitions. Right? Now there is another field that is called artificial intelligence. It is full of algorithms. It is not with the data. It doesn't deal with the handling of data. It doesn't have the handling of the data. But we have so many algorithms to process the data, to analyze the data. Like there are so many fields are there in the artificial intelligence, like symbolic AI, reasoning, knowledge representation, machine learning, natural language processing, NLP, that is neural networks and deep learning. Deep learning is very, very interesting and very powerful. And neural networks, it is also another, it is coming from the neural network. Artificial neural network was there. The next level of the neural network, it leads to the deep learning concept. So I think deep learning sessions are also going on. So I think you have some idea. But if you learn the deep learning, that is dealing with only the algorithms, you can understand that. Algorithms and how to handle the algorithm, how to implement the algorithm, and how to use the algorithm for our application. That's it. But if the data is very huge, what should we do? It doesn't deal with that. It will deal with how to analyze the data. What is the analysis of the data? If we analyze this data, what are the outcomes we are getting? That is only will be handled, right? And of course, this is the time to announce that this is just beside that you are seeing one robo, right? Humanoid robo. Actually, this was designed somewhere in the California or somewhere laboratories, and the same type of robo, it was designed in our organization also, and it is also working fine. It is able to recognize the persons whenever it is called the Abhimanyu. In KMIT, we have designed that Abhimanyu. If we say that hello Abhimanyu, it will recognize the person, opposite person, and it will give the shake hand, and it will say that hello, that person name. So that is the one of the invention what we have done in our environment. Okay, that is secondary. Why I'm telling you is that is also depending upon all these concepts. Okay, we have done with the artificial intelligence, but the next step, what is the next step? The next step is the big data. We have to handle a lot of data. Our brain is very powerful. Our brain is able to store so much of data, and it is able to process so much of data, but machines cannot do such thing. Even you are listening, even we are in the class, in this session, we are able to think about the outside the world. What is the Omicron is going on? What is the test match is going on? What is the review of that movie? And all these are, we are thinking. Our mind is able to think in different ways because we are having very powerful brain. So to mimic that brain, all of the scientists are trying to mimic the brain by using the artificial intelligence, meaning that it is completely based on the process. It is not about the storage. Storage is different, process is different, process or analysis is different, right? Now I want to give you a bird's eye view of all these technologies. The first problem is most of us are getting confused with different technologies and terms. I have to clear that first of all. We are thinking about the big data, artificial intelligence, deep learning, neural networks, and machine learning. Everyone is talking about so many things, all these concepts. But what is the difference between them? If you join for a course in one organization, data science, they will give one curriculum. If you go for the deep learning concepts, again you will get another curriculum. Both are the similar content. And if you go for the machine learning, that is also having the similar content. Then what is the difference where we are getting the problem? That's what I want to show you now. See here, bird's eye view of the data. See here, big data. It is a very big field, and it is the artificial intelligence. It is a separate field, and the artificial intelligence, it is handling. It will use the data available, meaning that if you want to analyze, you should have some data. How to handle the data, that will not be dealt by the artificial intelligence. That will be dealt by the big data concept. Big data or data concept. See, big data and data, I am considering both of them as the same in our discussions. Okay. Please see that. If I am specifying that as the big data, that comes under the data also. Now, see here. Now, as a part of the initially artificial intelligence was very different. A theoretical part, completely the theoretical part and the algorithmic part. And based on the statistical learning and the statistical analysis, based on the mathematics, another field was developed that is called the machine learning. It was also adapted by the artificial intelligence, meaning that the machine learning was has comes under the artificial intelligence. Actually, it is not the part of artificial intelligence. Some part of the machine learning is artificial intelligence. Basically, it is starting from the statistical learning, right? It was started as a separate field, and then it was included in the artificial intelligence. And then it deals with what is the specialty of the machine learning? It is able to predict the future based on the old information, and it is having very powerful algorithms like regression concepts. Hello. Yeah, it is having so many advanced concepts, advanced learning techniques like regression, classification, SVMs, decision trees, random forests. All these comes under the machine learning technology. But the data is huge, slowly increasing. So analysis has become very difficult. So and the complex data is generating. So that complex data is not able to manage by the machine learning. So because of that reason, the new technology was developed, new algorithm, new paradigm was developed in the predictions. That is called the neural networks. Actually, the neural networks was also started from the mathematical terms and mathematical concepts only. That was also taken into the artificial intelligence, because it is all these are related to this essence only. And even the neural networks was implemented, that is the artificial neural networks. From neural networks, it has given with the artificial neural networks. The artificial neural networks they are solving some problems which are not able to solved by the machine learning, and but they are also having some limitations. If you want to go into depth, if you extend the neural network say a lot, meaning that if you increase the depth of the neural network, then it has become the deep learning. But if you are going to the deep learning concept, the neural networks occupy so much of data. It requires it requires to hold the so much of data. If you increase the neural network as the deep learning, then it is a huge amount of data is generated as a part of the deep learning. I hope you are listening the deep learning concepts also as a part of this workshop. In the deep learning, you are having some CNN and image analysis and all. You are training the models. If you train the model, so many parameters are generating. You just identify, you just try to find how many parameters are generating. If you design one neural network or deep neural network, that is the CNN, if you generate the convolutional neural network, how much data is generated, how many parameters are generated, you just analyze. For each layer, if you increase the number of layers, if you increase the size of the layer, obviously it will increase a lot. Then where should we store this much of parameter? I'm not talking about the parameters and the CNN concepts in this session. Here I am dealing with data only. So where should we store this much of data, these many parameters? Millions, billions, trillions of parameters are generating. Where should we store? We have to store somewhere. So we need big data again. And now we may have one idea now that there is some hidden relation between the big data, artificial intelligence, machine learning, neural networks, deep learning. Of course, deep learning and neural networks, they are having very close relationship, and the neural networks and machine learning, they are having similarities, and artificial intelligence and neural networks and machine learning, they are having so many similarities. So these machine learning and neural networks comes under the artificial intelligence now. Now it is combining with the big data. Then what is that field called? That is called the data science. The data science is dealing with all these concepts. Because of this reason, if you go for the data science course, you will get all these concepts. You will cover all these concepts. I hope you get the clarity now. Any questions here? For 2 minutes. For 2 minutes, any questions here? Because this is the most confusing concept. You can just type. Did you get the clarity here on all the concepts which are confusing in the current society, in the current era? Did you get the clarity now?
So there's a
Yes,
question in chat
the
box,
cloud
sir.
means it is the application of the data science. It is application of application of all these concepts. Cloud is another way, another view of the same concepts. Collection of resources. Here in the data science, big data also, we are using collection of resources. The collection of resources comes under cloud. Yeah. Okay, fine. I think it is over now. I mean, I think it is sufficient for now. Now I want to enter into the next concept. Now, data science. What is the data science there? Data is available in the various forms and various sources. See here, all these are the various sources of the data. See here, these are the sources of data. It may be from the cloud. Data may be from cloud. So much of data may be available in the cloud that has to be taken. And it may be in different formats. It may be in the Word format. It may be in the PDF format. It may be in the manual records or anything. And we may have the database also. We may have the data in the database format and archive format. It may be the streaming, continuous data may be there. And there may be the current affairs. And there may be the social media also. So all these are the various sources of the data. And it may be the structured or unstructured or semi-structured. Structured data means it is having the fixed structure like tables. tables are the best example for the structured data. It is having fixed structure and unstructured. The paragraph, if you use English, then you can design the paragraph with different formats, different grams, different styles. The same thing can be expressed in different ways. And semi-structured, some data may be structured, some data may be semi-structured, meaning that there is some structure, but we don't know whether there is a structure or not. Like examples are and fixed size, we don't have the fixed size, and XML formats, XML, HTML, all these are comes under the semi-structured. And data might be useful or irrelevant for a particular purpose. The decision maker has to take the data, take this data, entire data, and he has to take the decision. If he starts collecting all this information and analysis, it will take 1 year or 2 years to take the decision. Meanwhile, our requirements are also completed. So it is not possible. So the data science, we have to take the help of data science. It takes the data and it produces the data product. Data product meaning that it is actionable information. Of course, if you want, you can use the data product directly, or you may give some makeup and you can do some extra things onto that, and then you can use it. And the data product can be taken by the decision maker, and then he can take the decision. Now, the formal definition, it is not standardized. So many researchers are agreeing with this. Data science is an art of turning data into actions by producing the data product. That is called the data science, right? And there are various branches of the data science. Already we have seen that data science is based on all the concepts of the big data, machine learning, neural networks, all these are there. And recommendations, if you open the Amazon, there are the recommendations, weather forecasts and stock market predictions. All these are the applications of the data science. You may feel that these are the applications of the machine learning, deep learning. Yes, obviously we are dealing with data and analyzing, so it comes under data science field only. Don't think that data science is a separate field. It includes all the fields, right? Now, how to handle the big data? Is it the client server architecture? Now I am coming back to the big data concept. Now data science is over. Now we are going with the big data. Client server, three-tier architecture. Is it possible to handle the large amount of data with these two? See here, the client server architecture means only one server will be there, number of clients will be there. All the clients, they have to send the request to the server to store the data and to process the data also. So the server is responsible to hold the data and also to process the data as per client requests. So these are the two important things about the client server architecture. And there is a single point of failure. The problems are single point of failure, and server may be overloaded, and it requires high configured machine because the large amount of data is there. So we cannot afford that, even more than supercomputers. Of course, nowadays supercomputers are also not there. This is completely another technology like cloud. You may say that it is the cloud. What is the cloud then? The cloud can be also built on top of these technologies only. The cloud can be built, but background is again the same technology, the big data concepts. So come to the point. See, solution for the big data, distributed system. This is the solution. Instead of storing the data, large amount of data at one place, it is better to distribute the data. That is called the distributed systems. Instead of storing the data, entire data in one machine, different machine. How to think about two things: distributed storage and distributed processing. These two are the major things which we have to deal. For their purpose only. Of course, so many other distributed systems are there and big data concepts are also there. I'm not dealing with them. I'm just talking about two things. There is the Google and Hadoop. Right? Are you getting the connectivity? Is that clear? I'm just confirming. First, we have discussed about the data, various sources of data in healthcare, how many how many ways the data is generating, and then we discussed about the healthcare applications on the data, on the large amounts of data. The background of the most of those applications are Hadoop. As a part of that, we discussed about the data science to clear the what is that big data, Hadoop, and data science and machine learning and deep learning. And then we started with the big data concept. Again, come back to the big data concept, and we are dealing with Hadoop. Now we are at Hadoop. Now Hadoop concept. What is the Hadoop? It is the open source software framework used for distributed storage and processing of data set of big data using map-reduced programming model. This is called the Hadoop concept. This is the definition given by the Hadoop 14 only. It is a framework. It is not the tool. It is not the software. It is not the separate software. It is not the application. It is not the tool. It is a framework, meaning that framework means it has to be developed on top of one language, right? Which framework it is? On top of Java. On top of Java. It is the open source Java framework for the distributed storage and the processing of the data sets, right? Now, in Java, so we are taking that it is Java. Now, in Java, what is the communication program in Java? Basic communication program in Java. Can anyone say that? I think you may have that idea. I think RPC, remote procedure calls. I think you know that. So remote procedure calls can be implemented in Java to communicate with other machines in the network. So the RPC, so many RPC, remote procedure calls are required. So all these are designed in the first phase of the Hadoop development. That is called the core Hadoop. So core Hadoop is having the communication between the various Hadoop, various tools and various environment, various communication tools like RPCs with the different missions in the network management that will be handled by the, that was designed in the core Hadoop. And of course, we are not going with that. And then on top of that, there is the Hadoop distributed file system. On top of, once if you are able to communicate and transfer the data from one place to another place in the network, then you can design the another application here. That one of the thing is called the Hadoop distributed file system, HDFS. Once if you have storage of the data, you have to process that also. That processing is called the MapReduce. And Yarn. Yarn is another version of the MapReduce. We can call it as another version of the MapReduce. Now, let us go with the history of the Hadoop. Actually, Hadoop was started by Apache. Actually, one project was started in Apache long back, and that is the Nudge project. It is a search engine. They want to design a search engine. As a part of the search engine, they need to work on the large amounts of data. So one of the person who is working in the Nudge project, he is called the dog cutting. He is working on the Nudge project and he needs a new environment, so that he started working on that new technology. And at the same time, Google published their papers like Google File System and MapReduce. They published two papers. One is the Google File System and second one is the MapReduce. So by taking those papers, he implemented the same concepts on his own and in the Apache. So he has given the name as the Hadoop. What is this Hadoop? Actually, you can find him on the picture, and you can find a small yellow stuffed elephant. You may feel that, I think most of you are feeling like this only. The symbol for the Hadoop is elephant. Why they have given the elephant? Any any guessings? Why the Hadoop was representing with elephant? Is there any reason behind that? In general, big size, yeah, 90% of the 90% of the professionals, they are understanding like that only, but it is not correct actually. Not in the big size. Actually, it was the toy. It was the toy of the dog cutting son. Okay, he used to call that toy as Hadoop. He is very small kid, and he used to call that as Hadoop, not Hadoop, Hadoop. So he liked that word and he liked that symbol also, so that he has given the same symbol and name to his new product. This is very funny, but he only revealed this in one interview. Okay, so it is not for the big size. It is not for the large amount of data. It is not for the big data. The symbol, it is just unexpectedly it was given. Of course, it is connected to our big data also because of the elephant size. Okay, now, so he has given the name as Hadoop. After that, he joined in Yahoo. He resigned in Apache and joined in Yahoo. In Yahoo, he implemented the Hadoop a lot, and most of the companies they contributed to the development of the Hadoop because it is open source. Since it is the open source, anyone can implement. So the Hadoop was implemented like this. Cloudera contributed so many things, and Yahoo is also contributed. The core Hadoop was, most of the core Hadoop was implemented in Yahoo only. Okay, and then Hortonworks implemented, Facebook implemented one concept. I remember that it is the Hive only, and LinkedIn, it has given the pig concept, implemented the pig concept, and eBay, and all these are the concepts. IBM also contributed, Twitter contributed. All these are the most of the companies are contributed the Hadoop development. Because of that reason, it is not belongs to a single company. Hadoop is not belongs to a single company. It is the contribution of various things. So various companies, various organizations. So all of them combinedly, they have started the commercial support for the Hadoop with the Cloudera. See this Cloudera. The scalability, it is scalable, flexible, and fault tolerance, open source, fast, and cost effective. Scalability means you can start with a single mission to thousands of missions. Okay, first paper published on the Hadoop, in that they have implemented the Hadoop cluster on 3,600 machines all over the world, so that they have achieved that. And then scalable, it is very scalable, meaning that you can implement only in one mission also, and you can install in one mission also. Flexibility, it is more flexible with the different platforms and different environments. And a fault tolerance, if you lose one node, you can recover that from some other place. And then open source, it is the open source, anyone can implement. And fast, very fast, because it is a distributed environment, so it will give very fast response. And cost effective, you need not use high-end servers. Whatever the servers available with you, you can use them, and you can deploy one cluster with the Hadoop environment, right? And see here, the Hadoop ecosystems, there are so many Hadoop ecosystems are there, meaning that on top of Hadoop, so many are developed. Actually, the Hadoop means the combination of HDFS and MapReduce only. Initially, the Hadoop means it is the HDFS, that is Hadoop distributed file system, and MapReduce, combination of these two, that's it. That is comes under Hadoop. And then the MapReduce has to be written, the applications of the MapReduce have to be implemented in Java. But Java programmers are very less. Java programmers are very limited. So the Java programmers, since the everyone need not learn Java to work on the missions. So many SQL developers are also there. And another problem is MapReduce. With the MapReduce, we have to write each and everything. So it will take long time to implement the applications. So because of that reason, so many was developed, R connectors are developed, and Hive was developed, Uzi was developed. On top of all of them, some other tools are also developed, like whatever I have given the 9 tools, list of 9 tools. They have developed on top of, they have used all these frameworks, right? So I'm giving the base, and on top of that, there are so many applications developed on various domains. In the healthcare domain, they have developed their own projects and tools, and in the defense, they have developed on their own, and in the financial area, they have developed on their own. So like this, there are so many have developed like this. And Hadoop ecosystems. See here, this is the original Hadoop ecosystems. See here, in this, we have the various categories of the Hadoop ecosystems. I don't want to spend much time here. I want to explain you what is the HDFS and MapReduce much. Okay, so data ingestion, all these are the data ingestion. Data ingestion means taking the data into, putting the data into HDFS. That is the main aim of the ingestion tools. Apache Flume, Scoops, all these are comes under the data ingestion tools. And data distributed programming tools are here. Okay, and in this only MapReduce is there. Other than MapReduce, there are so many other distributed programming models are available, and NoSQL databases. MongoDB is there, HBase is there. HBase, MongoDB, all these are comes under NoSQL, and column oriented databases are this, and document analysis, and then key value pair analysis, and then graph analysis. If you are able to analyze the graph analysis, you can go with the images also, and so many things are there. And SQL on Hadoop, SQL is possible with the Hive and HCatalog, and all these are available. Of course, you did not learn all of them. At least one is enough in each technology. And frameworks are there, and security is there, and then metadata environment is there. Machine learning techniques are there. Mahout, Weka, Cloudera, Oryx, and all these are comes under H2O. All these are comes under the machine learning environment on top of Hadoop. Okay, and Tableau, and all these are also data visualization techniques which are easily connected to Hadoop, right? So I hope you are able to understand what is the level of Hadoop. So it is spreaded over all the concepts, right? Now we will enter into this. Of course, companies, so many companies are using Hadoop. All the companies nowadays, everyone is using Hadoop. Okay, actually compared to last 2 years, now everyone is thinking about Hadoop, because deep learning was implemented a lot from last 2 years, but now it has become the storage problem and a processing problem, environment problem. So everyone is again rethinking about the Hadoop and Spark. Now prerequisites, what you should have to learn Hadoop. That is, you should have the good personality, meaning that mental personality, meaning that you should have the curiosity and creativity, focus, like that. You should have some additional qualifications which you cannot learn from somewhere. You have to build on your own. And also the technologies, Java, Oracle, MySQL, operating system concepts, and distributed systems. These are required. And if you know, for example, operating system, Unix operating system or Linux operating system, then you can easily understand Hadoop HDFS. You can play with that. And if you know Java programming, then you can play with MapReduce. You can enjoy with MapReduce if you know Java very well. And if you know Oracle or MySQL or any database concepts, then you can enjoy with Hive, Scoop, and Speed. And of course, Spark is also there. So many other components are there. I'm just giving some examples, right? And now let us see about the distributed storage and how the HDFS is storing this much of data. I'm not going in depth with the architectures and all. I'm giving the overview of these architectures and how they are working. I'm going to explain. Now, see here, we have seen that the distributed environment is suitable for large amount of data, and HDFS is also there. Hadoop distributed file system, it is on top of the Hadoop core, right? Now, how it is dividing the data and how it is storing in different places. See here in this example, I'm showing that 3 machines are available. 150 MB file is available, and we can divide this 150 MB file into 64 MB blocks. First is 64 MB block can be stored in one machine. Next 64 MB can be stored in another machine. Next remaining 22 MB can be stored in another machine. So that in this way, the 150 MB file can be divided into several parts and each is stored in different places. Because of this reason, you can, here I am giving you in the 150 MB only. If you have 150 GB, if you have 150 terabytes, how can you store? So that you have to divide that into different parts, 64 MB blocks, and you can store over the network. Wherever you have the space, you can store that. Whenever you require, you can retrieve it. That is a simple thing, right? That is a distributed storage environment. I hope you are getting, right? Yeah. Now let us go to the next one. Now processing. Now we have the storage. Yes. Okay. I have 1 terabyte data, and we can divide that 1 terabyte data into 64 MB, 64 MB bit, 64 MB blocks, and we can store in different places. That is okay. Now, how can we process that? If you want to process, already the data is distributed in different places, different machines, distributed storage is there. Now, if you want to process, the process can be initiated at one place. That is, see here, in one machine, we are having the process. That process can operate on the given data, which is available in the same machine. But what about the remaining data, which is available in another machine? It has to be transferred through the network and it has to be stored here, and then it can process. This is a technique, general technique, which we will use. But in such case, the problem is this machine may not be able to hold that much of data. All the blocks may not be able to store in the single machine. And another problem is this is a single point. The process is executing in single point, and it will take a long time. So instead of transferring, and another thing is we are wasting a lot of bandwidth. We are wasting a lot of bandwidth by transferring the data from one place to another place. So to solve that problem, distributed process was introduced. In the distributed process, instead of transferring the data from one place to another place, that process will be copied into different places wherever the data is available. If some data is available in one machine, a process will be copied at that place. In all the machines, wherever the data is available, in all places, the process will be initiated. Once if it is created, then they will produce their own outputs. They are the local outputs. All those local outputs have to be aggregated by another process, and that can produce the final output. So it is called the distributed process. Hope you are getting. Right? Yeah. Now, is it clear? Any questions in this? These two concepts, the distributed storage and distributed processing. Yeah, I think I'm going forward. Now Hadoop. What are the ecosystems of Hadoop? HDFS. It is a distributed file system that runs on the large cluster of commodity machines. And see here, this is a large cluster of storing. This is a storage. HDFS is the storage. And MapReduce is the processing. Distributed data processing model and execution environment that runs on the large clusters of commodity machines. Commodity machines in the sense, our regular machines. You need not go for the specialized missions. You can go with the regular missions. You can design one cluster and you can work. And Hadoop ecosystems are there. If you are not comfortable with the MapReduce, you can go with the PIG concept. It is a very good environment. You can write some data flow environment. So you can write the data flow language. And Hive is another distributed data warehouse. I hope you understand the distributed data warehouse. It is not for the operational data. It is for the historical data. So distributed data warehouse is provided by Hive, and it manages the it manages the data which is stored in the HDFS, and it will provide the query language based on the SQL, so that by using SQL you can retrieve the data easily, which is available in the HDFS. Right? These are the two other tools. And already I have the data in databases, existing databases. Now I want to analyze with HDFS. Then I should have some tool to retrieve the data from the database into HDFS and HDFS into database. For that, we have to use some tool, that is
Sri Ram Jai Ram Jai Jai Ram Sri Ram Jai.
hello.
Hello, 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 hello.
RSM check. Some Pushpendra Arundragi, kindly mute your audio, please.
Yeah. So the database, an interface to communicate with the database and the HDFS, that is by using the scoop, right? And scoop is the tool designed to efficiently transferring bulk of data between the Apache Hadoop and the structured data storages. It may be Oracle, MySQL, or any databases. And I have the large amount of streaming data and also log data. Log data is. And how can we handle this much of data? How can we store this data into HDFS? There is the data ingestion. So we should have some tool to store this much of data in the HDFS. That is called the Flume. So Flume is the distributed, reliable, and available service for efficiently collecting, aggregating, and moving the large amounts of data into HDFS. Right? So these are the various tools available for Hadoop. Now we are going with the HDFS architecture. Yes, is that clear? Now we are going with the HDFS architecture. Now, the HDFS means it is the distributed storage environment. Distributed storage environment. In the distributed storage environment, see here, it is a cluster. By using this cluster, you can make a cloud also. Okay, so see here, it is a cluster. The cluster means it is a collection of resources. Here in this HDFS, all the resources are the servers only. Now, if you have a file, I want to save this file in the cluster. How can we store this file in the HDFS cluster? That is, it will be divided into several blocks. Generally, it is the 64 MB. In the advanced versions, meaning that the latest versions of the Hadoop, it is having 128 MB. Okay. So the block 2 will be stored here, the block 3 will be stored somewhere. So like this, how many number of blocks? That is depending upon the size of the file. And let us say, for example, if you want to get file 1, then you have to take from this machine, this machine, and this machine, and this machine. In case, if any one machine is failed, what is the situation? We will miss that block. So to avoid that situation, the blocks are replicated into other machines also, meaning that the same block will be, another replica will be maintained for any block in another machine. This is called the replication factor. How many copies will be maintained? That is called the replication factor. Okay, so the replication factor may be, in general, it will be 3. 3 is the replication factor, general replication factor for HDFS cluster, not default. Okay, you may get one doubt that there may be the inconsistency if we do this, if we replicate the blocks. No. Why? Because the Hadoop and HDFS restricting the users to update the data. Once if you create a block, you cannot update that. There is no availability of updating the data in Hadoop because it is the historical data. History cannot be modified, right? So this is the historical data, so we cannot modify that. So there is no chance of inconsistency. So the data will be stored in the form of the blocks. Now see here, in this, the data is available in different machines in the form of the blocks. Now if you want to retrieve file 1, you have to take different blocks from different places. who will tell you the file block 1 is belongs to file 1, block 2 is belongs to file 1? Who will tell that? And where it is available, who will tell that? That is, we have to maintain a table that is called the namespace. We can call it as the namespace. That namespace has to be maintained, like file 1, block 1, it is available in the node 1, 2, node 1, 3, and file 1, block 2, it is available in node 2 and 5. Okay, like this, there should be some table should be maintained. That is called the namespace. And where should we store this namespace? For that, we can give one dedicated mission that is called the, since that mission is storing the namespace, that is called the name node. And all other nodes are storing the actual data, so they are called the data nodes. And don't think that it is the client server architecture. All these are servers. All of them can communicate directly, meaning that the node 1 can directly communicate with node 10. It can transfer the data on its own, meaning that it is not the client server architecture. It is looking like client server architecture, but it is not the client server architecture. Only the instructions will be given by the name node. All the work will be done by the workers. All these are the workers. These are the data nodes. Right? This is the basic architecture of the HDFS cluster. Of course, what are the components of the name node? What are the components of the data node? That is another big issue, big story. Okay, I don't want to touch that. How it is maintaining and all. And see here, one more thing. If one node is failed, then another block, another copy of the block is available, so we can recover that. That is okay. If the data node is failed, but if the name node is failed, then so because of that reason, they have introduced the backup node, and of course, secondary name node is also there. Checkpoint node is also there. Active name node and passive name node concepts is also introduced, so that the whatever it is, the one backup node will be maintained to maintain the reliability on the name, right? So this is to handle the failure of the name. Okay. Now, hope it is clear. Did you get some clarity? Did you get some clarity on this? Yeah. Okay, then let us continue. Okay, I will answer the, yeah, if there is anything, I will answer later. Next. Now we'll go with the next one, the client. Okay, we have the Hadoop cluster, HDFS cluster or Hadoop cluster. Then how can we interact with that cluster? All the machines involved in the cluster, they can communicate easily. There is no problem. But others, how can we communicate? That is, there will be a client. The client, if the client want to communicate with the HDFS, then it should have the HDFS file system interface. Through that HDFS file system interface, it can communicate with the HDFS. It can communicate with the HDFS. So through this, it can communicate with the HDFS and it can retrieve the data and insert the data into that. And let us say, for example, if there is a user application, if the user application is also having the HDFS file system interface, then it can directly communicate with the cluster. Otherwise, it has to communicate with the client, which is having the HDFS file system interface, and then it can come. This is the process of the user application and the client concept. Okay, the client can write or read the data from or into file in the HDFS, right? And it is a single writer, multiple writer. Single writer means only once you can write. Once the block is written, you cannot modify that. Already I told you that. So this is the client server. This is the client concept of HDFS. Now, how the data will be written? What is the process to write the data? As we have seen that if a file is available, let us say, for example, if a file is available, then the client is having one HDFS file system interface, right? HDFS file system interface. This file system interface, it will verify the file and it will divide the data into several blocks, and then the client will request for each block. It will send a request to the name node to write this block onto HDFS, right? And whenever it gets the request, the name node grants a lease to write the block onto the data node. And also it will specify where it should give the replicates also. What are the replicates? The same block has to be replicated number of times. In this, I'm assuming that there is the replication factor is 3. So 3 copies of the block should be stored. So the 3 copies are made where these 3 blocks have to be stored in which locations, the list will be given to the client. And then the client, because of the HDFS file system interface, it creates a pipeline to connect with all the data nodes which are having the facility to store the block. And then once if the pipeline is generated, then it starts writing on the first node. That node will write to the next node, that write will write to the next node. But the client will write only once, that will be replicated internally in the HDFS. This is the writing of the data. Now, for all these blocks, the same process have to be continued. Depending upon the client capacity, it can go with the 1 by 1, or it can go with the multiple blocks at a time, parallel, so that the process can be fast. Right? This is the writing of the data. After completion of that, it will revoke the lease and then reading of the file. If you want to read a file, anyway, a file system interface is available. It can communicate with the name node and it will get the list of files and list of blocks and locations where it is available to the client, so that the client will select the closest block. Closest block in the sense, generally the cluster is in the different countries. Data node 1 may be in India, data node 2 may be in Japan, data node 3 may be in Germany, like that. So which is the closest block, it will be selected, and after selection of that, it will read the data from that selected block. Of course, if it is not available, then it will go for the next block, next replica. So this is the process. This is the reading process of the data. So I hope it is clear. Yeah, next I'm going with that. Next one, steps for execution of a process. Now, what is the process of execution? I'm just introducing the map reduce concept now. It is a regular process. The process will take the data in general and it will produce the output. And if the data is very large, then what is the solution? Distributed storage. The data will be stored in different places, data 1, data 2, data 3, and then the data will be given to the process 1, and then it will give the output. There is a problem with this solution. Already we discussed about this. So because of that reason, all the blocks of the data, that is the parts of the data, they will be taken as the input splits. For each input split, a separate process will be created, and that process will produces the output for that particular data part. That is called the intermediate output. That intermediate output will be given to the another process. That process will aggregate all these outputs and it will give you the final output, right? Final output. Now, the process which is initiated for the each and every input split, that is called the map process. And the process which is initiated for aggregating all the intermediate outputs, that process is called the reduce process. So map and reduce processes, right? This is the strategy of the map reduce concept. Now let us see a small example of this. Actually, it is not the exact example for the map reduce, but I'm trying to make you clear what is the map reduce paradigm. Now see here, array of elements are there. I want to find the calculation of addition of all these elements. If you are working on the regular process, you have to initialize a sum variable s as 0, and you have to add the first element to this, and then you have to add the next element, and next element. Let us assume that each addition is taking 1 second. Each addition is taking 1 second. How many elements are there? 9 elements are there. 9 times addition operation has to be performed, so that for this 9 seconds are required. Now keep it aside. Now I am applying the map reduce concept. The data is divided into several parts. See this, all these are the various parts divided. Now For each part, a process will be generated. That is 1 plus 2 plus 3 and 4 plus 5 plus 6. This will be performed and it will generate the intermediate outputs, and then they will be given to the reduce process so that it will aggregate all these things. Now, how much time is required for performing this operation? Please let me know. Please give your answer. What is the, how much time it will take for completion of this process? Anybody, any answer? 5 seconds? 5 seconds is enough. Let us calculate. For this, 3 seconds required. For this, 3 seconds required. For this, 3 seconds required. And for this, 3 seconds required. Total, how many seconds required? 9. How it is 9? 3, 3, 3 plus 3 is also there. Actually, it is 12, but all these 3 processes are executing in parallel. So that for all of them, 3 seconds only. 3 plus for reduce 3. So it will take 6 seconds only. It is lesser than the original process, regular process. So it is taking just 6 seconds. Okay. This is only for understanding, not the original MapReduce concept, right? And one more thing is there. If you have very small data sets, don't go for the MapReduce. Don't go for the Hadoop concepts. It is suitable for large data sets only. It is suitable for large data sets, not for the small data sets. Okay. Now, this is the process of MapReduce. Now we have to go with the MapReduce. The MapReduce framework. It is a framework for the parallel processing and the commodity machines, and it breaks the process into 2 phases. One is the map phase and reduce phase. Already we have seen that the maps will be created for the splits and reduce will be created for the outputs. How many number of outputs are there? Those many reduce processes will be created. And how many input splits are there? Those many map processes will be created. They are called the mappers and reducers. In the map phase, we will have the mappers. In the reduce phase, we will have the reducers. The reducers will handle how many reducers will be there, how many required outputs are there, those many reducers will be created. How many splits are there, those many mappers will be created. Okay, and the input and output of the map and reduce are key value pairs only. The map process will take the key value pair and produce the key value pair. And reduce also will take the key value pair and produce the key value pair, right? And the user can define the map and reduce methods. The user can define the map and reduce methods. They will be inside the mappers. And let us go with that map phase. The map phase, it will take the input from the input split and process it, and it will produce the intermediate output. And also it will store in the local storages. And it partitions the output into number of regions depending upon the number of reducers. The number of reducers are depending upon the number of outputs. So, and then a separate mapper will be created for each input split, and each mapper invokes the user-defined map method. And the map method can be invoked any number of times. How many number of times? That is the number of records or lines available in that particular split. Those many number of times the map method will be called. And the output locations, anyway, the process is completed, the outputs are generated and they are stored in the local storages of the machines where they have executed, and those locations will be shared to the job tracker. Job tracker comes into picture here. And the job tracker, the reducer phase, the reduce phase, it will take the data from it will take the input locations from the job tracker, and the job track and the reduce process will start working on that for their outputs, and they will merge. Number of mappers are there. From all those mappers, they will be combined, they will be merged. All the outputs collected from the different mappers will be combined, and they will they will start working on. And the process the merged data and produce the final output. Each reducer invokes the user-defined reduce method. The reduce method, we have to define that. Okay. Now, what is job tracker? What is the task tracker? Task tracker means all the machines in the cluster. Please remember that it is the not HDFS cluster. It is a separate cluster. In the machines, all the machines except one machine, we have to install the task tracker. It is a process that is placed in the machines in the cluster. All the machines except one machine is having the task tracker. And the task tracker can handle the mapper or reducer. Either mapper or reducer can be handled by the task tracker. And the job tracker means it has to manage all the task trackers. That is called the master process. The master process, it will handle all the task trackers. And map reduce program workflow. I want to go with the workflow. See, here there is the application available, and the application is having the map reduce library. The map reduce library, actually we will give the data also. Where is the data? The data location will be also given. The first step is the map reduce library will divide the data into several splits. Okay. Here it is divided into 3 splits. In this example, 3 splits. This is called the input data. And also what the MapReduce library will do is the user application will be copied into all the workers where it is executing. How will we know that? How many mappers are required? How many splits are there? Those many mappers are required. Already splits are designed by the MapReduce library only. So those many mappers, and how many outputs are required, that will be given by the user. The user will specify, I want these many number of outputs, so that the number of outputs will be, depending upon the number of outputs, number of reducers will be created, and the application will be copied into all these, and then it will get relaxed and it will hand over the process to the master node, and then the master will start working with the workers, and those workers will work according to the masters, and whenever it is ready, then the master, of course, these are the mappers and reducers. The master will send the signal to the workers to start their work, so that the mappers will start working. They will take the data from the corresponding splits, and then they will produce the intermediate output. The intermediate output 1, intermediate output 2, intermediate output 3 by the mapper 1, 2, 3. Okay. After that, the intermediate outputs will be divided into regions based on the number of reducers. All these are divided into regions, and that is called the partitioning. That process is called the partitioning, and this process will be done in the local storage. It is within the local storage, and after that, after completion of this process, the mappers will send the locations where the regions are available, that will be given to the master, and then the master will initiate, and the master will give the instruction to start the workers to start the reducer process. Okay. Now the reducers, the reducers will start working on that. They will take the locations from the master, and then they will collect the data from the corresponding regions. Reducer 1 will take the corresponding regions, then reducer 2 will take the corresponding regions, region 2. So, and then they will produce the final outputs. And then it will send the information to the master. The master will send the information to the application that the process is completed. Once the process is completed, it is responsibility of the end user to collect the data, that is output. The output will be taken by the end user only. So this is the total workflow of the MapReduce. And see here, and this process has to be done on the cluster machines. So what are the cluster machines? What are the components of that? And what are the placements? See here, input splits, that is the input splits and the outputs are stored in the file systems. Here the file system is the HDFS. HDFS is involved here, and we will have the master node. We will install the master node in one machine, and we will have other machines also there. And we have five missions in the MapReduce cluster. So one is occupied by the master, that is called the job tracker, and it is also called the master mission. And other missions are having the task trackers, as we mentioned. And see here, the task tracker can handle either mapper process or reduce process. Here, we don't have sufficient task trackers, so two mappers are handling by one task tracker. It is adjusting. So, and then it is producing the outputs. So this is called the placements of the components on the cluster. And on top of the HDFS, how can we deploy the MapReduce cluster? See here, we have the name node, we have the data nodes. In general, on top of the name node, we can install the install the job tracker. On top of the name node, we can install the job tracker in general. And on top of the data nodes, we can install the task tracker. Okay. And then see here, and the splits may be available in the different places, and wherever the splits are available, there the mapper processes will be created. And on other machines, the reducers will be created. So this is the concept of the MapReduce. And then the user-defined methods for the MapReduce. See here, the user has to define in the initial stages, the user has to define this map process and this reduce process only. Okay, if you want to go in depth, you can concentrate on the partitioning, you can concentrate on the input, you can concentrate on the output, you can concentrate on the various formats of the inputs, various formats of the outputs, and so many you can involve if you are going in depth. But basically, if you are able to provide the map method and reduce method, that is enough, right? Yeah. And then now, of course, word count example I don't want to discuss at this moment because time is running, so I'm not discussing about this at this moment. Okay, yeah, this is just the process which how it is executing the MapReduce paradigm. This is the MapReduce paradigm for the execution of the MapReduce program. And now MapReduce is completely based on the Java program. Sorry?
தெரியலங்க சார், என்னமோ அப்டேட்னு கேட்டது. நான் உங்க சிஸ்டம் வச்சிருக்கீங்கல்ல, அதுல கொண்டு போய் போட்டு பிரிண்ட் எடுத்து.
So yeah. Now let us go with this. So MapReduce is very tough because completely on the Java. So because of that reason, Pig was introduced. Pig provides an engine for executing the data flow in parallel in the Hadoop. And it includes the Latin, that is called the Pig Latin language, and which can be used for the easy programming. Okay, and it is the data flow language. Data flow language means there will be one data set. We will apply some operation on the data set. It will produce another data set, and then again we can apply another process on that and produce like this. Okay, now Pig philosophy: pig eat anything, pig live anywhere, pigs are domestic animals, and pigs can fly. All these are the various pig philosophy, meaning that pig eats anything means it any type of data can be handled by pig. It may be the structured, unstructured, semi-structured, anything can be handled. And the pig live anywhere, meaning that on any type of environment it can work, it can execute. And they are domestic animals which can be controlled easily. The domestic animals can be controlled easily, so that the pig can be controlled with the programming. So it is the thing. And pigs can fly. It is a new thing, meaning that it can go with high speed. Okay, and how the pig will work? See here, there is a HDFS and MapReduce. On top of that, pig will be installed. and we have the various things here. We have the pig script. The pig script will be given to the parser. It will verify the syntax and then give it to the optimizer, which will analyze and how to execute that. It will create a plan and it will be compiled. The compiler converts the pig scripts into MapReduce programs, and then the MapReduce programs will be executed by the execution environment and then on top of HDFS. This is the pig concept. So all these are for the, you please remember that there is a lot of sensor data is generating, lot of records are also available in the healthcare. So all those have to be handled very nicely. To handle that, we can use all these tools. Pig is one tool. It is a very easy concept. And Hive. If you are very good in the database concepts, then we can go with Hive. Hive is the data warehouse framework, and I don't want to describe more and more. It is almost similar to the SQL. You can write directly the SQL statements on the given data, right? And it is suitable for the structured data only. If it is a structured data, then only we can use Hive. See here, there is a HDFS, there is the MapReduce, right? On top of that, there will be the Hive. The Hive will maintain, it is providing the DML and DDL statements, and it is having the repository, meaning that table schema, this data metadata, the metadata will be maintained. That is called the meta store. The meta store will be maintained separately other than this HDFS. Okay, so to handle this, we can go with the MySQL, or the MySQL or any other database can be used for handling this metadata. In that, we will have the table schema. Actually, in the HDFS, all these are the flat files. For that, it is providing the schema. A schema will be maintained in the Hive environment only. So we can create a DDL statement that will create a stable schema for the available data. And then if you execute one DML statement, the DML statement will be converted into, DML statement means select star from employee, select statements. Those select statements will be converted into MapReduce program, and those MapReduce programs will be submitted as the applications, and they will execute on top of the HDFS. They will use the data from the HDFS, right? Please remember that the Hive is providing a database-like environment for the flat files. The data is not generating through Hive. The data can be generated by some other application or the flat files. That for those flat files, we are creating a table schema and then we are using that. Please remember this point. This is very important. Hive. Okay, like this. Hadoop will be there. Hadoop structure is there. Hive is there. In the Hive, there is the meta store and there is the driver. There is the command line interface. There will be the web interface. You can open the web interface also. You can execute the servers. And if you want to connect with some other languages, you can connect with some other languages, and Thrift server will take care about that, and it can be connected to the Hadoop. Right? And then now the problems with MapReduce. Either you can use the MapReduce or Pig and Hive and Pig Hive, anything. They're the common problem. All these are the common problems of Hadoop. So see here, the problems are, see here, this is one MapReduce application. This is one MapReduce application. Within the Pig program or Hive, within the Pig program, statement 1, statement 2. The statement 1 is this one. The statement 2 may be another MapReduce application. For this, for the statement 1, it is taking the data from the HDFS and processing it and writing back to the HDFS. And for the next statement also, it is taking the data again from the HDFS, writing back to the HDFS. So this is the time consuming process. Because of this reason, they are very slow for very large data sets. So we have to reduce that. How can we reduce that? Of course, number of IO operations and no reusability. Once if you write the MapReduce program, you cannot use that for another purpose. And of course, for the Pig and Hive operations, and need to use the streaming tools like Flume, Kafka. You have to use the streaming tools. That is the data ingestion tools. You have to use the data ingestion tools. And time consuming for the machine learning algorithms. It is very difficult to use the machine learning algorithms on top of MapReduce, not suitable for this. And additional libraries are required for the graph processing. It is also challenging task. So we are going with the next architecture, alternate to the MapReduce, that is the YARN. YARN means yet another resource negotiator. Very simply, we can say that, we have the job tracker and task tracker, right? You can simply assume that the task trackers are the node managers. We can assume, okay, not exactly same. The task trackers are the node managers. This is the job tracker. Actually, the job tracker, original MapReduce, job tracker is having two responsibilities. One responsibility is, job tracker responsibility is to handle the resources and to the resource manager was designed separately and application was removed from this. So it has become the resource manager only. For every application, an application master will be generated. Otherwise, what happens, if you, for the MapReduce environment, if you submit 5 jobs, each and every job will be executed individually in the parallel execution only. But all these 5 jobs will not be submitted at the same time. They will be waiting in the queue. After completion of the first application, next application will be submitted. Because the job tracker has to take care about the resources as well as the application also. In the YARN introduction, in the concept of the YARN is, the resource manager is separate and application. If you submit 5 applications, for all those 5 applications, if there is a sufficient number of processors in the cluster, the separate application masters will be generated. And number of applications will be started in parallel, so that the process will be fast. That is a YARN. Okay. On top of YARN, see here, YARN is introduced between the HDFS and MapReduce. Now the MapReduce is also part of the client for the YARN. Now pick application programs, they will be connected to the MapReduce. They will be given to the MapReduce. The MapReduce will be submitted to the YARN. The YARN will use the HDFS. So this is called the HDFS MapReduce pick hive by using YARN, right? So this is the concept of this, and we have the Spark also. We have the Spark. Because of all these disadvantages, we have another programming model that is called the Spark. It is the computation framework. Please remember that Spark is the open source cluster computing framework. Cluster computing only, not the storage. Spark doesn't have the storage. And it is very fast and expressive performance, very fast. And development, and it is developed in the California, University of California, Berkeley. And that is it is donated to the Apache, and it is very compatible with Hadoop. So see here, this is the Spark architecture components. See, there is the Spark core. On top of Spark core, it is having the RDD, resilient distributed data set. Actually, in the HDFS, the data is distributed among the different missions hard disk, meaning that secondary storages. There is a file system, but the Spark is also almost similar. The difference is the Spark uses in memory, meaning that the data is distributed but only on the memory. So there may be some limitation on the size, but it is sufficient for the data, okay, for our application. Now RDDs are there, and on top of RDDs, again there is the same problem. If you don't want to use the RDDs, you can go with the Spark SQL. It is also part of the Spark. Okay, Spark streaming is also available as a part of the Spark. You need not use another libraries. Okay, another tools, directly Spark is having, and Spark is having the ML library also, M library, and also Spark is having the deep learning libraries nowadays. There are so many deep learning libraries are also implemented on top of Spark. Okay, and graphs processing is also very easy with Spark. Okay, all these are the various modules on top of the Spark core, and it can execute on top of the standalone scheduler, meaning that in a single mission, or on top of the yarn, or on top of the mesh OS. We are selecting the yarn so that the data can be available in the HDFS. From HDFS, it will take the data and it will perform the operations on the data available in HDFS. Right? And Spark versus Hadoop. For the batch processing on the Hadoop, we have the MapReduce, Pig, Hive. Of course, you can write the Java programs using Java MapReduce. And in the Spark, we have the RDDs. Okay. And for the SQL library, for SQL querying, we have the Hive in the regular Hadoop. And in the Spark SQL is there. Spark itself is having the Spark SQL. And for the streaming and real-time data, we can use the Strom and Kafka and the Flume. And for the Spark, we have the Spark streaming separately. And for the machine learning, we have the Mahout in the Hadoop. And in the Spark, we have the machine learning Spark ML library, Spark machine learning library. And real-time lookups, there is no SQL concept. HBase Cassandra is there in Hadoop, but in the Spark, there is no specific tools available, but we can handle some no SQL concepts. And see here, in the Hadoop is the distributed storage and also distributed computing. But Spark is only distributed computing. It is having the MapReduce framework. It is a generalized computation. And it is using the disk. It is using the in-memory. Spark is using in-memory. And not idle for the iterative work. It is very nicely working on the iterative because it is on the in-memory. And the batch process will be there. And it is much faster than Hadoop, Spark. And it is compact code. It is having the compact code. It is using, you can use either Java, Python, or Scala. Any language, if you know any one of these languages, you can play with Spark. Okay. And shell or ad hoc exploration is also there. See here, the RDDs, the difference between these two is, see here in the MapReduce, we are having the application after completion of the application, writing back to the HDFS and giving back. And see here in the Spark, it is loaded once and it is given to the next computation because it is in memory. It is cache. It is in the cache, and final result only will be stored in the HDFS or S3. That is Amazon's. So RDD1, if we can perform some transformation so that it will create another RDD, and then we can apply another transformation. It will generate another RDD. We can perform some operation that is called the action, so that it will give the output to the client. So this is the RDD concept. Okay, this is a read-only collection of objects. I don't want to discuss much about this. Yeah, I think most of the time is over. So see here, this is the RDD. It is a Hadoop cluster. On top of that, there is the Spark cluster. RDD is here, and see here, the file is available. Yeah, see here, the file is available in the HDFS that is loading into the Spark shell by using the Spark context, and it will create the RDD on the Spark shell. Okay, Spark environment. And this is the code in the Scala to create the Spark shells. Okay, to read the sample.txt, this is the code, and this is the data available in that. Okay, these are the operations. These are the different operations. Collect is one action. Okay, we are just displaying. Okay, and then of course we can use the text files, all these are. There are two types of operations are there on the RDDs. Transformations and actions are there. Transformations means RDD to RDD will be given, and RDD to results, final results will be given. These are the things. And Spark SQL, for the Spark SQL, SQL context and Hive context are there, and these are for the Spark SQL. And for RDD, we have the Spark context. This is enough. Spark context is enough. And this is the concept of the Hadoop environment. And now definitely Hadoop and Spark will be the added advantage for your healthcare data. Okay, because it is able to handle large amount of data sets. For more details, you can go with this link. I can, if you want, I can paste this link also on your chat box. Right? So this is what I want to share with you. If you have any questions, please proceed.
Thank you, sir. Thank you for a wonderful presentation. Dear participant, if you have any queries, you can unmute yourself and or just raise your hand. We will unmute you. You can raise the question, or you can post your question in the chat box. Dear participant, come forward to ask questions. I think this session is a wonderful eye-opening session on basic of big data, and from the scratch, sir, I have explained what are the tools are there, big data applications. So, dear participants, it's a good time. You can come raise your questions and you can verify whatever the doubts you have.
Actually, this is a huge topic. We cannot cover in 2 hours, but I tried to cover most of the things.
Dear participant, you can post your questions in chat box also.
Yeah, thank you. So I will paste the link also. You can go through it actually. Yeah, this is the link for the paper related to the big data components. Yeah, thank you. I think.
Thank you, sir. I think
No questions?
nice.
Okay. Okay, then thank you. Thank you for your support. Thank you for giving this opportunity.
Thank you, sir. Thank you, sir. On behalf of Knowledge of Technology EC department, I really once again thanks for your accepting our invitation, sir. It's a wonderful session and it's a
Thank you,
highly
sir.
valuable session, sir. Thank you for the presentation.
Thank you.
Thank you. Thank you very much. Thank you.